welcome to STEMAC. We today gonna learn about something new which is known as enthalpy. So what is enthalpy? It is known as the total heat content of a system. It's like a heat bank which consists of all the energy of a system. Like the chemical reaction we see, like when H2 plus O2 consists of a new compound. So here what happened, the energy gonna exchange into them and gonna create a new system and new thing which is known as a heat bank, and this new system contains with so much energy. So why this thing is important? So it helps us predict whether a reaction is exothermic and endothermic. Next we're gonna learn about that topic individually. So second, it shows how much energy is transferred in a reaction. It can be either absorb some energy from a system or either can release some energy in that system. So how we determine this energy exchange? We identify it as a del H, which is change in enthalpy of a reaction from a reaction. So here what happened, del H change in enthalpy in a reaction, the product energy, heat of the products minus heat of reactant. That's how we determine the del H, the enthalpy. So changes in enthalpy either can be negative or positive. It depends on how much energy it absorbs and how much energy it releases. So for the real life examples, we see that food burning in our body. After we consume food, it needs to be break down into small pieces, and to breaking down it need to release energy, as like just look, we need to cut it down from every part. So as we cutting down, it consists some of molecules, some energy. So when we cut into small pieces, that energy gonna be released from it. So that's what happened in our food burning in our body. Those food break down and release energy, and this case is described by enthalpy. So next, cooking rice or boiling water, it absorbs energy. So whenever we cook rice, first it is normally our normal room temperature. Then when it get into the hot water, it absorb the water heat, and then it gonna produce some food for us. And lastly, chemical or cold hot packs. This chemical, we learn that chemical compounds are break down or get together and produce a molecule or a chemical elements. So when they get together, that chemicals components gonna causes enthalpy changes when they are activated finally. Next we're gonna learn about the exothermic and endothermic reaction. Now we're gonna learn about exothermic reaction. So what is exothermic reaction? It's a chemical reaction that releases heat to the surroundings, the environment. It's gonna release some energy, which we learn in the enthalpy, that in that reaction energy either gonna absorb or either gonna release. So in case of exothermic, it's gonna release. So as the heat are releasing in the surroundings, so what gonna happen? The surrounding is cold. Just imagine that there is a cave, and there all the heat are present here. It's like 100 degrees centigrade, and here it's cold. So when here a break gonna happen, they release some heat here, and the cold environment gonna vanish, and the all situation gonna be in normal temperature as the heat are released here. So for the examples, for burning wood gonna release some that gonna release some energy in the surrounding. You feel some heat around you when you stand in front of burning woods. So consumption of fuels and mixing water with strong acid. So in that cases, what happened actually? Product have less energy than the reactant. It's just here A plus B is C come out. Here what is written here? Product have less energy than reactants. So here are the reactants A and B, and C is the products. So that C gonna have less energy than that A and B. So often occurs spontaneously. Spontaneously it gonna happen. here for the example, again some example, it neutralize acid and base and produce salt water, and as usual as the heat is released here in exothermic, so their heat release happen. So in case of respiration, glucose plus oxygen, carbon dioxide and water and energy here again release, as this is exothermic reaction. So in general formula, this reactant is reactant to products plus energy. As the energy is released here, the energy gonna go into the surroundings environment. So what is the fun fact about it? That things, it all combustion reaction are on combustion reaction, the combustion of fluids we learned there, that reaction are all exothermic reaction. So for the quick tips here, it's the negative del H, heat is exiting, like we learned that it released, so you can remember it from exo to exit here. So now we're gonna learn about the graph here. So here the energy of reactant, so we learned that energy of the reactant gonna be more, so here the more number here and the less number for energy of products. So here in that cases, that part explain the activation of energy, as the energy curve is here more in case of energy reactants, and here with a small amount which is the energy released in case of an exothermic reaction. Next we can learn about endothermic reaction. Now we gonna learn about endothermic reaction, which is a positive reaction. To know about this one, first you need to understand what is the endothermic reaction. It's a chemical reaction that absorb energy from the surrounding usual as heat. It's different from exothermic, that as exothermic release energy and in that case absorb energy. You can remember that when you can remember the points if you compare with the exothermic reaction and the endothermic reaction each other, then you can able to remember all this information. So in case of endothermic reaction, it's a positive reaction. Why? It absorbs energy, that means that product is gonna have more energy here, so it's a positive environment in that case. So what is the characteristic here? When it absorbs energy, so surrounding environment temperature gonna be decreases, as the energy gonna get inside the products, surrounding energy gonna be in a little bit less number. So the same one, products have more energy than the reactants, so reactants gonna, when through the use of reactants the product gonna be happens. So here in case here, so what happened, that A plus that energy gonna be absorbed here. So as the energy absorbed, so that products gonna be produced, that's why products has more energy in that case of energy. Like here just A, when I get the excess the energy here, that product gonna be produced, so it has more energy than the A here. So it requires continuous energy input. To produce that product, we need to put energy continuously, as the absorbment is required here. So for the example is the photosynthesis, plant absorb sunlight to produce food for them. So in that endothermic reaction, that products gonna be produced for the plants. So melting ice, solids absorb heat to melt and turn into liquid. So in that case endothermic happened. Cooking absorb heat to change raw food to cook food for our consumption. So the general formula here, reactant plus energy, which we get to know here, just reactant A, that energy, and with the product C gonna be produced. So fun fact here, that food needs energy to undergo chemical changes. So when we eat food, that food go through some processes here. So when that food energy consumed, at that chemical changes happen, and at the end we got the product with that we consume, and in that cases endothermic reaction happen. So now we're gonna learn about this graph here, as we get to know all the important information here. So here it's the reaction, direction. That way all the reaction gonna happen, reaction gonna continuously proceed that way, and the energy consumption gonna be here in the, just imagine that at x and y. In x way that reaction direction gonna be happen, and in that x way y way energy consumption gonna happen. So here energy of reactants, that is the energy of reactants as usual. Activation of energy is that amount of energy activation. In that other cases, in the previous exothermic, we see the curve was there. So that means that there is less energy in case of product. As here we learned that absorbed energy gonna happen, so products have more energy, so the energy absorbment gonna have the biggest number here than the endothermic reaction. Energy of product is energy absorbment happen, and you can remember the endothermic in a short way that energy gonna be in the products, so you can endo to in. That's how you can remember endothermic. And that's all for enthalpy, exothermic, endothermic. Next we're gonna learn about new topic. Thank you everyone.